Hi guys, I can't believe well, of course I can believe I talked that much. That ran over the 15-minute allotment for the other thing. So here are the last couple of problems. So for 26, here, when you multiply them, you just write the first one. F of x is 16 times x to the 1/3, and g of x is 2 times x to the 2/5. So you multiply them together. The 16 and the 2 give you 32. Here you have to add the exponent. So you're going to need 15ths in order to add them. And you would have 5 15ths here and 6 15ths here. 5 plus 6 is 11 15ths. And remember, you can put those in your calculator. In parentheses, 1 divided by 3, close that parenthesis, and then plus in parentheses 2 divided by 5, close that parenthesis, hit enter. It'll give you a decimal, and then you go math, frac, enter, enter. And you should get 11/5, and you put that as your exponent. Then the domain is all reals. You can take the cube, the odd root of any number, so that one's all reals. Now when you divide them, I just wrote them as a division problem. The 8 and the 2, or the 16 and the 2 simplify to 8. And then you have to subtract the exponents. And that's what this is. So it's 5 minus 6 this time. And so it's negative 1/15. So the part with the negative exponent, just the x, that goes in the denominator. And that's 8. And then x cannot be 0. It can be any number it wants for f, any number it wants for g, but you can't have 0 in the denominator. If you plug in 0, you're going to get 0 to the 2/5 is 0, and the 2 times 0 is 0, so you can't have 0. Okay, f of x, you have 16 to the 1/3, and then in parentheses, put your other f of x, 16 times x to the 1/3. Power to a power, it's 16 to the 1/3 power. That's what this ends up being. And then 1/3 times 1/3 is 1/9. That's a 9. Here, 16, I simplified 2. It's 8 times the cubed root of 2. We're taking the cubed root of it. The cubed root of 8 is 2. That's why this comes out. And you get 8 cubed roots of x to the 1/9. Again, you can take the cubed root of any number. So the domain of f of x is real. All real, and then the domain of the answer is also all real. There's no denominator. Then this one you have to plug in negative 32 into g. So when you put it in here, negative 32, the fifth root of negative 32 is negative 2. Negative 2 squared is 4, so it's 2 times 4, or 8. And then this isn't done. Then you have to put 8 into this. The cubed root of 8 is cubed root of 8 is 2, and then 2 times 16 is 32. So the answer, the answer for that one should be 32. See what I mean? I don't like that I can't write. The last, and then I wanted you to do f of g of x, so that's down here. It's put this inside, and it's the 1/3 power, so it's 2 to the 1/3 times x to the 2/15, because you multiply power to a power, and then you simplify it. And I just left it like that. Oh, that should be 16. That one I can change. So 16. Okay, now we can go back to that. So that should be 16. Maybe I can put a text box right here. I'll do that in the answer key and repost it. Okay, and then for the last one, so that's 16, and then 27. These two, you just multiply the domain. You put any number in here. You cannot put any number. X cannot be 0. Can't be in the denominator for g of x. So you are limited to all reals except x equals 0. This one you're dividing. Again, g cannot be 0. Even though the answer you get looks like it can be anything, you have to go back to the original domains. The original domain of g of x is not equal to 0, all x's except for x equals 0. So your solution can't be at that either. C, here 1 minus this. I typed it in already. This squared gives you this. Add these two. Well, you're subtracting these two, they are 0, and then change every single sign. Distribute that negative all the way through, and you end up with this. And then when you put negative 5 in to f first, You get 1 minus 25, which is negative 24. Then you plug negative 24 into 1 over x, and you get 1 over 24. Oh, 1 over negative 24. So let's fix that one. Or you put the negative here, and then that should be it for that. The last problem I asked you to find g of f of x. So you put f of x, which is this, into the denominator. Then the domain is interesting. It started off, it cannot be 0 because 1 over x cannot be 0. So that is a limit. But also, if x is 1, you want to think, when is this equal to 0? So that means, when is x squared equal to 1? X squared is equal to 1 when you plug in 1 or when you plug in negative 1. So this one is a tricky domain. The domain cannot be 0, 1, or negative 1. And then the last problem we'll go over in class. I didn't do that one. So if you watched all of these, way to go. Way to spend 21 minutes of your weekend. Have a good rest of the weekend. Bye.